I don't even know how I started this box, so we're just gonna go with it. Okay, have you ever heard of the terms, this stinks, acid or base?
Yes.
Yeah, can you give me an example of an acid?
A lemon.
A lemon. What does it mean? An orange. What does it mean if something has acid or is acidic? What does it look like?
Like that?
Like that? You think that this is acidic?
I don't have an answer.
You don't have an answer?
Why do you think that's acidic?
Oh, bubbly.
It's all
It's all
bubbly.
So you think that acids are bubbly, maybe?
It's a good observation.
Yeah.
Okay.
Okay, so you know, you can give me an example of an acid. Can you give me an example of a basic? No. So basic is like the opposite of an acid. It's a different kind of, it has a different kind of charge. So, have you ever heard of the word an ion? Yeah, can you tell me what an ion is?
It's in an atom.
It's in an atom.
Part of an atom. And there's like a positive and a negative side.
Yeah, it can have a positive or negative charge. Yeah, that's right. So an ion is part of an atom or molecule, and atoms and molecules are all around us, right? And so the reason that we're learning about pH is because it's important for the human to know the pH of something. So scientists a long time ago created this thing called a pH scale. Have you ever seen this before?
Nope.
No. So a pH scale is how we rank an acid and a base. So if something is 0 to 7, it's an acid. If something's 7 to 14, it's a base. And if it scores a 7, it's just neutral, which means it's safe. So for humans, we don't want something that's too acidic, or we don't want something that's too basic, because it can hurt us. Does that make sense? So ideally, we aim for something that's like a 7. Make sense? Cool.
Okay, so now we're gonna do the experiment. So we already mixed this, which was, what 2 ingredients were in this one?
Strawberry jam.
Okay, what do you guys think happened when we started mixing it together?
Combined.
It combined? Okay.
Yeah.
Alright, so we have 2 different solutions. We have number 1 and we have number 2. So we're gonna add number 1 and I'm gonna stir it, and I want you guys to think about what's happening and observe what actually does happen.
Before you do though, go ahead and draw what you see in the picture on the first cup.
It's pink. Yeah, close enough. It doesn't have to be perfect. We're trying our best. Why do you think it's that color?
The strawberry jam.
Because it's strawberry jam. That's a good idea. Okay.
Do you guys want to maybe predict what's going to happen when we put solution number 1 into this mixture?
It's gonna overflow.
It's going to overflow.
Have an explosion
It's
maybe?
gonna bubble.
It's going to bubble. Alright, let's see.
So what's happening?
Turn black.
Turn black. So maybe the solution made it change colors. Why do you guys think it made it change colors?
Strawberry jam didn't like it.
The strawberry jam didn't like it.
Let's get off.
So do you think that there's maybe some kind of reaction that's happening when we added the first solution into it? Okay, so go ahead and draw, after we added the first solution, what color it might be.
Purple.
Purplish color.
Kind of dark.
Yeah.
Remember, it doesn't have to be perfect. Good coloring, Carly.
Thank you.
Alright, so after we add solution number 2 into the mixture, what do you think is going to happen?
Carly, you said you had an idea what you think this was earlier. What do you think liquid 2 is?
Vinegar?
Vinegar?
Why do you think it's vinegar?
I don't know.
Just
Because
guessing.
we said it was stinky.
Yeah.
Looks
Jen,
like
you think
water.
it's
And it's clear.
Do you guys want to predict maybe what's going to happen when we add it in here? Because the first one you said it was going to bubble or explode maybe, and that didn't happen, right?
I think it's in a bubble.
It's going to bubble? Okay, let's see.
There's bubbles in it. It turns back to red.
So what happened?
Turn back to red.
It turned back to red.
Why do you think that happened?
I don't know.
Okay,
acids and bases, and then we're gonna get into exactly what happened in this experiment, okay? So acids and bases, when we taste them, sometimes have a certain taste. So when you think about tasting an acid, which you said could be a lemon, what does it taste like? Sour, very good. So basics sometimes taste bitter. So one's sour and one is bitter, but we can't always taste everything to determine if it's going to be an acid or a base. So scientists come up with a different way of determining if something was an acid or a base and where it fell on the chart that Miss Anderson made. So we can see. Perfect. Okay, so the H in pH stands for hydrogen. Have you ever heard of the word hydrogen before? Oh, okay, what's hydrogen? Can you give what it is?
A chemical, a gas.
A gas.
Okay, very good. Okay, have you heard of the periodic table?
I heard my sisters did it sometimes.
Okay, has she told you about what happens on the periodic table, or? No, not at all. What about? No, not at all. Okay. So hydrogen is an element, and it has unique properties about it. So there's many different types of elements, but in this, with pH, it's all about hydrogen. Hydrogen is the main thing that happens with telling if a liquid is acidic or basic. So if we look at this picture, the H's stand for the hydrogen. Do you guys have an idea what the O might stand for? Maybe another element you've heard of?
Oxygen.
Yes, very good. Okay, so if something is acidic or an acid, it has more hydrogen ions. So you see how there's like a little plus? Remember we talked about ions? It either has a positive or negative charge. So it has a plus. What do you think? It's positive or negative?
Positive.
Positive. So these hydrogen ions have a positive charge. Are there more hydrogen ions, or are there more of this OH with a minus sign? More hydrogen ions. So if something is acidic, it has more H pluses, more hydrogen ions. So if we go onto this side, the OH, that stands for hydroxide ion. So it's kind of sounds similar, both start with an H. But the hydroxide ions, do you think there's more of those or more of these hydrogen ions on this side?
Hydroxide.
More hydroxide. So bases have more hydroxide ions, and acids have more hydrogen ions. So that kind of helps scientists be able to tell. So the first liquid that we added in was ammonia, which is a cleaning supply. And that is, if we look at our picture on our pH scale, that is at an 11. Yes, so the ammonia, have you ever heard of ammonia before?
No.
No, you might have smelled it a little bit when we were working with it. It has a very distinct, strong smell. It's a cleaning supply, so it cleans really bad stains and works through those tough stains. So that's at an 11. So is that closer to the 14 or closer to the middle of the 7? Is it kind of in the middle?
Closer to the 14.
Closer to the 14, you're right. So do you think that it's more of a dangerous chemical, or do you think it's something that you could drink? Remember we said we want to only drink things that are around the 7, right?
Dangerous.
It's more dangerous, yes. So when we added that chemical in, it turned purple to tell us that there was some kind of chemical reaction happening. So it changed the water into that purple color because it was a base. Our second ingredient was vinegar. So you were right. So if you look at vinegar on here, it's on the other side. So that tells us that it is an acid. What number is that on?
3.
3. So is that closer to the 0 or the 7?
0.
Closer to the 0. So you probably wouldn't want to just drink vinegar, right? That would be taste kind of funny. But you can have it in small amounts. Anything else you want to add?
So, have you ever seen, do you guys have pools at home?
Mhm.
You do? No. Pardon me, so you know. So sometimes when you have pools, they have these little test strips that you take and you dip it in the water and it tests the chlorine, right? And the strip turns colors. It'll either turn like a dark purple or like red. So the strawberry jam was kind of acting like that strip. We like to call it a pH indicator. So it's not that the water was changing colors, it was that the jam was changing colors. The jam was telling us that the liquids we added were either more basic or more acidic. Does that make sense? Do you guys have any questions? What do you think of it?
Oh, it's cool.
Do you want to be scientists now?